Good morning, good afternoon, everyone. We're just going to get started in a minute or so. I can see some more people are coming in. Just wanted to welcome you all, and in a few moments, we'll begin. Hi, everyone. Good morning, good afternoon. Thanks for joining. I know a few people are coming in, so I just have a few announcements before I pass it over to Andre, our host. Just to let you all know that the webinar is going to be recorded. So in the coming days, I'll send a recording out to everyone. You should see a questions tab in your GoToWebinar panel. Feel free to ask questions throughout, and we're going to try to get to as many as we can on the webinar. Please keep them as much on topic as possible, and whatever we can't answer, we'll try and get back to you in the coming week as well. Also, last thing before I pass it over to Andre is at the end of the webinar, we have a short survey that's going to pop up. If you can just take those 10 seconds to just give some feedback, and also you can suggest topics for future webinars. We really want to provide the most value and content for you all. So I want to thank you all for joining again, and I'm going to pass it over to our open source evangelist, Andre, who's going to be talking about performance testing with Docker containers.
Hi everyone, thanks for joining, and this is Andre. I hope you took your bottle of beer, some coffee, maybe mate, and you will spend this hour learning something new and valuable and use that in your daily job. The topic for today is performance testing with Docker containers. I'm planning to do the quick recap on Docker and Taurus as the tools that we use. We will be looking at demonstrations on how we use the pre-built and our own Docker images to do performance tests. We will look into some of the best practices and aspects of and nuances of how we use Docker images and Docker containers with performance testing tasks. And we will slightly touch on reporting and cloud scaling aspect in the context of Docker container usage for load testing. The containerization trend exists around us. It's been several years since Docker started to gain its popularity, and it definitely conquered the world. And the concept of Docker container is quite simple, and yet it's strong. The Docker container presents the isolation concept for application when you can have the same host operating system serving separate applications for applications to not know about the existence of each other. And this is the strong concept that enables you to get to certain features, to important features which simplify their daily life of computer engineers. Some of the key features of Docker includes all-inclusive application packaging approach. This is really strong when everything you need to run your application just sits inside a single container, single image, and you can copy it, you can transfer it to any location you want and run it there. You can share it with your colleagues. You can develop it locally and then put it into production or QA environment. This is really strong. The isolation of applications enables you to run within same operating system and same machine. It enables you to run many different applications, and that gives you the strength of developer environment running the full set of microservices, for example, without interfering with each other. And that's really important because the applications used to have dependency conflicts, and that was challenging to run different applications on the same operating systems. For that, we were usually taking virtual machines for the isolation feature. But virtual machines, they require a lot of hardware to run. And Docker solves that problem by providing a lightweight way of running isolated processes as opposed to isolated virtual machines. So it is very resource efficient. The portable feature of Docker means that you can build container in one environment and transfer it into other environment as an image and then run it on the other environment. You can multiply containers and run the same image of the Dockerized application in many different machines. There's even Windows-based Docker service available today, so it's not Linux only feature now, so you can enjoy the Docker features being Windows user and benefit from all of these interoperability of Docker containers. And last thing is the Docker containers are very minimal in terms of their footprint after you shut them down. They are disposable. When you run the image, you don't have to think of cleaning up something after you shut it down. It just destroys everything and you can start from the very beginning doing your experiments. The benefits of using Docker are massive. You can enjoy the versioned images, so you can simplify evolution of your application with deploying just a new version in a natural way. You just change the version of image and you restart it. There is huge repository of free images for popular applications, and we will use that today. One of the examples of those images is Taurus image, and we will also use the Python language basic container to build our own image. And if we will look a bit into the future, there is the cloud native and Kubernetes as the new wave of application infrastructure raising up. And that is happened because of the success of Docker containerization as a concept. So if you look into the future technologies, consider the Kubernetes and cloud native family of technologies for your future education and the professional development. Now let's quickly remember what Taurus is. We have a lot of past webinars about what Taurus tool presents. In short, Taurus is command line test automation tool. It is open source and it enables you to run JMeter, Gatling, Selenium, many different testing tools, providing certain convenience features around that. And it is driven by YAML configuration files. This is the modern way of configure things in our industry through presenting YAML file configurations. The website, the home for Taurus project is gettaurus.org, and you can just take it and play with it whenever you want. To demonstrate what Taurus is, we can just take some YAML configuration file. We will use that file today. So it presents the definition of what to do at which scale. This is the load testing profile for how long to run the test, and this is which steps to perform as part of the load test. Just one URL. I could have a couple of URLs here if I want, or I could do really complex things like HTTP blaze.com/parameter value. You can easily evolve your configurations and build tests from that. And then you run it from command line by typing bzt and putting the name of the YAML file. And the test will start. It will run default JMeter in my case, but this is really flexible. It will show you the dashboard with the live results from your performance test, some of the KPIs, how it works. You can see that the param that we have entered is immediately becoming part of my performance test. I can see the dynamics of how my virtual users kick in, how much throughput in terms of hits per second they produce, what is the health of my local machine, how much time should I wait for the test to finish, and many additional features on top of that. But today's focus is Docker specifics on top of Taurus. Let's learn how do we use pre-existing Taurus image. This is the case when you don't want to mess with building your own Docker image, which we will learn later today. Let's say we want to use pre-existing Taurus image. What is the biggest value of pre-existing Taurus image? It's that you have everything built into that image. If you want to run any kind of testing tool supported by Taurus, it's already inside that Docker image. You don't have to think about Java, Python, Ruby, JavaScript, Node.js, anything. Correct WebDriver with browser, nothing that you should bother about. It's all already installed and of correct versions inside the existing Taurus image. To quick start that, we will type the command. You don't need to stay in any of specific directories. We can just go into temporary directory, and the command to run the Taurus Docker image would be, I will just copy it for the sake of the speed. The command would be sudo docker run -it means that I'm running it in interactive terminal. This is important to see the beautiful dashboard. This is the name of Docker image, BlazeMeter Taurus, and last component is what to do. In this case, for the simplicity, we will just hit one URL of demo website. I push enter. It requires some sudo permissions. If the image is not existing on your computer, it would download the image onto your computer. But from there, you don't have to install Python, you don't have to install Java, you don't have to install JMeter, you don't have to install Taurus. Everything is bundled into that magic Docker image that contains everything you need to get this level of performance test usage when you don't need to really think about dependencies. And we will slightly touch on the CI use case later today. That's probably the most beneficial use case for you because you don't want to interfere with your neighbors. So it runs, it is fully functional, and To run that, you don't need to know much. Just one command that triggers the Docker execution of Taurus image. As I said, no installation, pre-existing, pre-installed everything, including Selenium use case, so you can go with your front-end testing also. How to make our own Docker image if we don't want to go with pre-existing image. Let's say we want some specific version of JMeter, or we have any other specific needs. In that case, you should prepare the Docker file. Docker file is the definition of image for Docker, and it is a file that is executed top to bottom by Docker daemon to create the image. Let's figure out what happens. First line is from. From means which image to use as base image for the Docker image we build. It makes sense to not start from the pure blank page. It makes sense to use some pre-existing images as your base layer. After that image, we use pip command to install Taurus. This is the command to install Taurus. Pip install bzt, and run is the instruction for Docker to execute this. After executing this command, there will be bzt available on the inside the Docker image. After that, we want to also install Java. We need Java for JMeter, so we will invoke the apt update and apt install of default Java package. Why? Because the Python package, Python Docker image that we use as our base operating system image, that Python is in turn built on top of Debian operating system, and these are the commands to install things in Debian. So after running this command, we will have the Java, the functional Java inside our Docker image. Next step is to pre-install JMeter into Docker image. And for that, you would use convenience of Taurus. bzt, there is special command -install tools, and there is an option saying that from the tools that Taurus knows, we only want to include JMeter. Finally, we want to state that our image by default invokes Taurus and passes the parameters to Taurus. This is the meaning of Docker file. As soon as you have the Docker file, your command to build the Docker image, I have the Docker file here. It's more or less what I've shown you with slightly more formatting on top of that. When you have this file, you invoke the command, which sounds like sudo docker build and current directory. When you invoke that command, in case you don't have the base image of Python, it would be downloaded and each of the commands would be executed. For the sake of the speed, I will use the cached by Docker commands history. So everything was already built, so we don't waste the time on the broadcast to actually download all of the dependencies. But this is where the beauty of Docker comes. If this works on my machine, it will work on your machine also because of isolation. So I know that the image was built, and this is the ID of the image. In Docker, in case you don't want to address by strange identifiers, there is the concept of tags. So we will add -t bzt1, which is the tag name of this image. So we will address the image by this tag name. We ran it and we can see that it was tagged as bzt1 latest version of it. Now we can invoke the next command After we've built the Docker image, the next command is to run it. Sudo docker run -it, we know it's for interactive, and now instead of JMeter Taurus, we will use our own BZT1 Docker image with additional parameters. Sudo docker run -it BZT1 http blaze-demo.com. Run it and it works. So we have our own small Docker image with JMeter pre-installed inside, and it runs the JMeter performance test. This is the very minimum that you need to run Docker-based Taurus. There is slightly even more minimal setup, but for the simplicity, I will just skip it. But you can have the load testing image, which would not require JMeter, but would use more simple executor types. It runs, it works as we expected. We can interrupt the process to proceed. Next thing is the best practices. There are a lot of details with using Docker containers, and let's touch some of them. Let's start with the CI. CI is the most, from my practice, this is the most beneficial thing for the development teams when the pains are so obvious and we want to remove those pains. Why? Because traditionally inside continuous integration machines, we try to build a software, and when we build several projects within the same continuous integration machine, they start to conflict by their requirements and dependencies. For example, we want to build one project that requires Java 8 and another project which is historically requiring Java 7. So we start messing with installing Java 7 and 8 at the same time onto continuous integration machine, and everyone is confused. Which Java do I run right now? And you need the configuration around that. And a lot of problems when the amount of packages increase, and all of our applications usually require tens and sometimes hundreds of dependencies. It gets out of control. It really gets out of control. With the Docker, with this concept of self-containing image, this is not problem anymore. You can build the image which will be used for for the unit testing, for compiling your application, and you will not interfere with your neighbors. So different projects can use the same continuous integration machine, same physical machine, and build completely different images with conflicting requirements, but there's no conflict because they are isolated. You can use one of the best practices with Docker is that you don't have to build the image as part of your Docker, as part of your Jenkins job, for example. You don't have to build everything inside the image that will go into production later. You can have several Docker images. One of them, for example, for unit testing, another for integration testing, and final for building the artifacts and final installation packages of your software. Or you can have the Docker image with your application. This is preferred as the resulting artifact of your Jenkins job, and there is the registry of Docker images where you can push your resulting application image and then deploy it by and then deploy it using, for example, modern Kubernetes offering from Google or AWS. there is the powerful caching mechanism inside Docker. So if some steps are repeating and result of those steps is unambiguous, then Docker will just reuse pieces of Docker image from the past, which speeds things up. You don't have to start from the scratch, yet the result is quite predictable. You get what you expect to get. The only thing to be aware of is that when you heavily rely on building a lot of images inside your continuous integration, you need to bother with purging from hard drive the images and layers that are not required anymore. That's a bit of maintenance task, which is usually done once. You can find the tools for that online, and that's pretty normal task of cleaning up for any operations or DevOps guy. That's the only possible problem I know from using Dockers in Jenkins. Otherwise, from my experience in JMeter, we use that extensively. We enjoy that, and it solved our pain of conflicting requirements. I can share that, for example, website for Taurus is built. If we will go and look into Taurus website here and get Taurus, this is ran from Docker container. We pack that and we deliver that into Kubernetes cluster, and it runs the app. So we don't have to think of the moving parts for the website, just because everything is contained inside Docker container, and it's built by Jenkins. Next thing to consider when you are using specifically for Taurus automation or load testing automation is two approaches of organizing your Docker images. And we already saw both of these approaches when we ran the Docker images of our own and pre-existing Taurus. First approach is to take everything you will possibly need in the future and bundle that into one big image. The benefit of that is obvious. You don't need to think if certain moving part or dependency is inside the image. You know that it's there just because everything is there. But it leads to quite large image, which you need to spend time downloading from your registry, and it takes some time, some space on your hard drive. So this is the drawback. And Taurus pre-built image uses this approach for the simplicity of use. This is what we want. We want people who want to start using Taurus to not think in the beginning, to not think about installing moving pieces or dependencies. You just get it, you use it, you try it. But if you want to have faster download, if you want to have faster, if you want to have less hard drive space, you can build your own Docker image and only include what you want. You can have one image per testing tool. Let's imagine the situation when we have several teams in our company doing load testing. One of the teams prefers JMeter, another team prefers using Gatling tool, and the third team is stuck with JMeter 2.13 by historical reasons, and they don't want to migrate onto newer versions. So we can have the Docker images per each team, which will be serving just exactly what they need with those dependencies pre-installed inside the image. The challenges that you expect there is that you need to manage those images. You need to make sure that you maintain them, you upgrade Taurus inside them, you upgrade JMeter, and it's generally more moving parts to look after. You need to get into building your own Docker images. The more images you build, the more you want to reuse pieces of that. which is also solvable through Docker base images. So it's up to you. I cannot say that one approach is better than another. Just choose whatever fits your reality and know that you are free to use that. As we saw, it is functional with both approaches. You can take Taurus pre-existing, you can build your own Taurus Docker image. One of the specific things you need to be aware of when you are using Docker, the isolation is great, but it means that the container is isolated from surroundings. So whenever you need to transfer test related files into container, for example, JMX file for JMeter, or when you need to take something out of container, like the logs of JMeter, the logs of Taurus. Taurus produces good artifacts which you can use to troubleshoot or to just review what has happened or to store the results of your tests. So you need to organize these file transfer from and into container. And when you transfer things out of container, there is permissions problem, because when you run the Docker by default, it runs under root user, and the files you take out of container, they are also under the root user permissions. It's just a thing to consider. You need to arrange the permission change before deleting these files or moving them somewhere else. To organize this kind of bridge between host operating system and the Docker container operating system, we use the -v command. -v command of Docker, or the option of Docker, it means that we need to mount some local directory of the host machine into container directory inside Docker container. So all the files that we have in local directory will be visible for Docker container, and any file change that Docker container will do to the container directory will be visible in the local directory of the host machine. Let's be more specific with that. So I have the JMX file of JMeter, which I want to execute inside Docker container. So I have to somehow put this file or share this file into Docker container, run it, and get the results out from inside the Docker container. For that, there is, in case you want to get more specifics, there is the installation page of Get Taurus, where you can find detailed instructions. At the bottom is how you access Taurus artifacts, how you share these files, and how you add the mounts. It's all here. Let's see by the example, how do we do that? So I want to run my small BZT1 Docker image, but now I want to put my file requests.jmx into container. I will use command -v. I will specify my current directory. I will use benefits of being on Linux, and I will use just current directory. And I will mount that as bzt configs. I will run bzt1 Docker image, and as a parameter, I will say, please run bzt configs requests.jmx. This is my command. Sudo docker run interactively, mount the directory, the current directory, onto Docker image as bzt configs. The Docker image to run is bzt1, and we ask it to run JMX file. Taurus knows what JMX file is, so you don't need to write the YAML configuration, and we run it. The directories will be mapped, and the JMX file will be visible by Docker image, and it will execute. We can see here that JMeter runs the JMX file. Whatever is inside that JMX file, it gets executed. We see the results, but we still don't get any output files from our Docker image. So we cannot see the JMeter log, for example, in case we see some failures and we need to figure out if we miss some plugins or some dependency files. How do we get the artifacts from the Docker image out? We see that the artifacts directories are created by Taurus in TMP directory. So to actually get the artifacts out, let's mount not as BZT configs, but as TMP. So we will mount the current directory into the TMP directory of the Docker image. You can mount several directories if you want, and you can have the layout that will be different. Let's be simplistic. This is the share instruction. Let's run it again, and we can see that there is new artifacts directory created here. Test gets executed. Let's wait for the first results, but I will interrupt the test so we will quickly see the artifacts. Let's interrupt the test. We see that the results were written as this directory. It ends with 449. If I will look into current directory, this is it. I got my files into this directory, which I mounted into container. And now I can get in and look into JMeter log and see what was happening there. Was there anything specific that I look for? Any warnings? No. I can also see the Taurus log, which is also a source for debugging information in case of sophisticated setups, and some other things like JTL files with errors from JMeter, or the YAML configuration pieces that Taurus has generated throughout the test. Whatever presents the artifact, the file from executing the test is there. What was JMeter printing into output of the process when I was running it? I can see it here. This is the way to transfer files into container and from container onto host machine. As I said, the files are having, the directories are having root permissions. We can see it here, that my original files, they all have my user permissions, but here it has the root permissions. To delete these files, I'll have to change the permissions on those onto my user, so I will be able to delete it. It's usually not a huge problem because Taurus is automation friendly tool, so you can put it into, let's say, CI flow where the permission change will be the part of regular commands, so you will never forget it. What's next? Limitations. One of the things to consider when you are using Docker extensively is that this beauty of running several containers within the same machine, these benefits come with the problem of noisy neighbors. And it's specific, it's quite specific to load testing, because load testing is supposed to take quite big amount of resources to execute the test. You drive hundreds of virtual users and they do hits as fast as they can, which consumes CPU, which creates the input-output flow on your hard drive. And you know that if you will run several tests like this on the same operating system, on the same physical machine, they will start to affect each other. So you will suddenly see the increase in response times, while this increase is caused not by the application under test, but by your local load generator being affected by parallel runs. So this is the thing to consider. You need to somehow understand that the noisy neighbors might distort your results. And this is the real problem of performance testing. Even without the Docker containers, if you are using the same hardware for running the several performance tests in parallel, they might start affect each other. Docker does not solve hardware scaling problems. So if your computer is only able to run, let's say, 1,000 virtual users for the specific JMeter script, you cannot have more than 1,000 virtual users on that machine if you will put it into Docker container and you will run several Docker containers. There's no magic, so the sum of virtual users you get on the same machine will eventually come to the same number. 10 Docker containers, 100 virtual user each other might be your top limit of this specific machine. Another thing to remember is that for the performance testing, you need to tune your operating system. There are things like numbers of limits for open socket and open file descriptors. There are things like TCP stack options like port reuse, what to do with time weight sockets, and all of the specifics of the socket memory on the Linux, for example. You still need to figure out which specific configuration you want and configure both your Docker image to have those settings and your host machine to have those settings. Docker has no magic to guarantee you best performance. You need to consider that. And disposable nature of Docker means that you need to bother to get the artifacts outside of Docker, because otherwise they are immediately disposed once your load test has finished. So storing the results for long-term storage is still the task to solve. But still, with all of those limitations, I would say the Docker and containerization, because of the isolation and portability of those Docker images, the benefits outweigh the problems. The reporting aspect. So from everything we saw until now, the things were happening inside the Docker container, but we usually do not we usually do not consume results in only textual form of these kind of reports. We want something interactive and nicely looking. For that, JMeter provides some of the reporting features which are easily available through Taurus by just adding the -report command to command line. You don't need to have username and password for that. You can just enjoy the report by adding -report to command line. Taurus will use JMeter reporting. There will be the hyperlink in the command line available to review after the test finishes. Let's have some data getting into reporting system, and after that we will review which report do we get after running this test. So we have some data. If I will interrupt the test, I will see the hyperlink here. And if I will open this hyperlink, I will see the results of my test. The thing is that, let's imagine Jenkins continuous integration job that has failed in the middle of the night. And for us to actually see the result, this is the hyperlink which we want to take in the morning and start troubleshooting the performance test from here and being able to zoom in and review what were the numbers, what was the I don't know, engine health or exact numbers of error rate. Well, we have error percentage 0, everything went fine with our test. And if you need to specify some additional API key, there is a way to override an option from command line. The environment variable BlazeMeter key holds my BlazeMeter API key, and I'm running the same command with adding these command line option, and Taurus will feed the results into my personal user space of BlazeMeter report, so I will be able to see the results as soon as they go in. Let's refresh the page. So the test is running right now, and I'm seeing the result of the test at the same time it's running. I can share this link, I can share this report, and important is that I can go back into history of my reports and see what was happening a week ago with the very same test. I can compare them and calculate the differences between the throughput or virtual users or response times of those. So I see these numbers. I can go, and this time I will see the engine health because I'm authenticated. I can see some logs. If those are uploaded, I can drill down into per second resolution of my report. This is the purposely built BlazeMeter platform for reporting. You don't have to have a paid plan for that. You can come and upload some of your results here. It is freemium. The test runs. I see the report. Everything is connected. So minus report works for Taurus, just add it in command line as usual. API key can be passed through -O option when you run the Docker image. To get artifacts out of container, you have to do mount, but if you have used BlazeMeter reporting platform, the artifacts are uploaded automatically. So this is why you don't need to bother by mounting any directory to get the artifacts out. You will have them in BlazeMeter platform automatically. You can download the zip file and have all of these files at your hand. Finally, cloud scale. When you need a lot of resources, you remember that Docker doesn't give you free resources. You need to have the hardware to run the Docker containers in case you need massive load. And you can use BlazeMeter testing platform for that. Because we actually run what I showed you today as part of the BlazeMeter cloud scaling platform, but instead of running one Docker container manually, we run hundreds, and we are able to run thousands of them automatically. For you, that will be only the one checkbox in GUI to run several thousand or several 100,000, sometimes millions virtual users around the world. And we have many geographic locations available around the globe for you, just the matter of choice from GUI. And also we have full support for JMeter and Taurus. Our host machines and images are tuned and have optimal settings for performance testing, so you will not be trapped by some typical problems. We have all the tools pre-installed inside our Docker images, and not only things that are shipped by default Taurus image, but even more. For example, different versions of JMeter. It's again just a matter of choice of combo box in UI or configuration file, and it's already there for you. And there is the nice UI to manage tests. You have the API to do some customizations. You can collaborate. You can share the results. You can work simultaneously and have really complex setups of load testing with JMeter. So now let's summarize what we have learned today. Docker and containerization is the modern way to distribute applications. It's good, and the benefits outweigh any of the problems you might find using Docker. Isolation and interoperability is the key benefits of Docker. Making your own Docker image is very easy. Takes just a bit of typing in the text file. The CI and containers is the most beneficial use case. So start doing that today if you don't do that yet. It will solve all of your pains or most of your pains with dependency conflicts inside CI. Load testing also benefits from Docker because we used to struggle with installing Java, installing JMeter, installing Taurus into operating systems. I know that pain because I manage the Taurus project and I present around the world, and I know how much people frustrate when something do not install on their operating system just because of some conflicts with their existing applications. And I know how easy for people to work around any of these problems by just using Docker image of Taurus. Thank you. And now it's the time to answer some of the questions that we got from the audience. And the first question is, can we get JMeter Docker container with install specific JMeter plugins? Yes, we can. And if we will look into documentation of Taurus module for JMeter, there is the plugins section inside modules JMeter. So in case we want those specific plugins, we prepare the YAML file with these specific plugins, and upon building the Docker image inside the Docker file, we would specify the list of those. It would be even like this -o modules JMeter plugins equals, and you would specify the list, something like that, and blah, blah, blah. And this command will start installing your own configuration of JMeter plugins into Docker image, so it will always be there. And as we know, if the plugin is standard and it's not there inside your image, it will try to download it anyway, because JMeter Plugins Manager tries to do its best. Next question. Is Taurus an industry standard tool? Does it work outside of JMeter? Yes. Taurus is an abstraction layer on top of JMeter and other tools. So you can consider it as one level up architecture layer on top of JMeter. So for example, there is community of Gatling tool users, which also take Taurus and use the features of Taurus on top of Gatling. They run their beautiful Scala files. They enjoy the benefits of Gatling scripting capabilities for the load profiles, but still they get the reporting features, the scaling features, and they can run those millions virtual users from Gatling by using JMeter cloud infrastructure. It will not change much for you if you want to use Gatling as part of your Docker image. You will use it like this, for example, Gatling. I will use Gatling here. So now if I will do the Docker build Gatling, and if I will run this image, it will start downloading the Gatling to make it part of this Docker image. Next question is, Can Taurus support master slave setup and its public managed memory heap example? If your question is specific to JMeter, I guess, there is, regarding heap size of JMeter, there is XMX, it's here, I think. Memory, yeah, JMeter JVM memory limit. There is a specific option. It's called memory XMX to configure for JMeter. And if you look for distributed setup of JMeter, it is supported. Just go to gettaurus.org, go to docs JMeter, and find those sections in documentation and read how you configure the JMeter master slave setup. There's no slave Taurus thing, just because it's the different kind of tool. But it supports the JMeter distributed mode if you wish. Next question is, in a CI pipeline, how do you pass or fail a build? Also, can you do a trending of results? Yeah, in the CI pipeline, there is the, let's go with like here, performance plugin. There is performance plugin for Jenkins. That performance plugin has support for Taurus tool, and this is how you do that from inside Jenkins. You run your test from inside Jenkins and make it to collect the results. The plugin site, let's see if it's better here. Documentation. Let me find the proper documentation piece for you. Yeah, so you can run the performance test, and you can also do this kind of performance trend when you have build by build and trend of the KPI per build. And there's many kinds of graphs you can get there. There's a whole ton of features. The thing you need to remember, it's called performance plugin for Jenkins, and it has full support for Taurus tool, so you can run whatever kind of testing tool you have with this plugin inside Jenkins and get these trending things. The last question is, what is maximum CPU utilization on the machine running a Docker container with Taurus that you recommend so that the results are not affected? I would say 80%. 80% is the threshold which, in my experience, starts affecting the Java processes. If you would go with some pure C++ based load testing tools, that threshold would be probably more like 95% of CPU. But if we speak of the most common and most popular JMeter, that threshold is 80%. Sometimes for some of the scripts, the threshold is not CPU. So you need to remember that it's not only CPU, it's the it might be the hard drive input output in case of intense result writing or source reading, and it can be the network. So you have to look at 3 KPIs: CPU, input output, and network input output, to make sure that you are not blocked by your load generator. And as I said before, if you don't want to be limited by hardware, you should use Blazemeter scaling platform to have the magic scaling of your load tests, and it's on demand, so you can just use it for the short term when you need that. So Thanks for listening. I think we will address more questions offline, and of course you will get your recording and use Docker. Thank you.
Once again, thank you, Andre, for the presentation. I know we have a lot of questions and we weren't able to answer them all. So as he said, we'll try and get to as many offline as well. And just to reiterate, the webinar is recorded, so we'll be sending it out hopefully tomorrow, if not by early next week. So thank you all for attending, and we hope to see you at our upcoming webinars. Oh yes, and last thing as well, that there is a survey that's going to pop up as soon as you leave. If you can take those 10 seconds to answer that and just give some feedback and suggestions for future topics that you'd like to see, we'd really appreciate that. So hope you all have a wonderful rest of the day. Thank you again to Andre, and take care, everyone.